Hello, Math 32 at Math-2, and welcome back. Today we're starting our very first lesson on permutations and combinations, which is going to be looking at the fundamental counting principle. So we're going to start here with this very first example. It says, we're looking at a toy manufacturing company, and they have three parts to their toys. One part is colored, the top part, which is colored red or white. Then you have the middle part, which could be colored orange, white, or black. And then we have the bottom part, which could be yellow or green. So how many different toys can be made? Well, that's many parts. So here's one easy way of doing it, and it's probably the simplest way, not the fastest, but the simplest way of doing it. So it's using a tree diagram. So first of all, if I look at this, we have part 1 here. Then we have part 2 here. Then we have part 3 over here. So part 1 is red. So I could go red, and then for part 2, we have the options of orange, white, and black. Okay, then we have white, and then we have black. Now that's for the red, but even for the blue, we could have orange, white, or black. Okay, now let's continue this. Here's my orange. My orange could go into part 3. From part 3, we could have yellow or green. Here, we could have, after this white, we could have still a yellow or a green. Yellow or a green. Here, same idea, yellow or a green. And here again, yellow, green, and then the last one is here, and they have a yellow or a green. Okay, now this takes a long time, but if I look at it, I could go red, orange, yellow. There's one toy. Or red, orange, green. Okay, every time I say or, what am I doing? I'm adding. So there's 1, there's 2. Or red, white, yellow. Or red, white, green. And so on, all the way down. So eventually, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different toys. Now, there has to be a faster way of doing that. And this could be very complicated. If I have, let's say, 5 colors here and 6 colors here, that'd be a huge tree diagram, hard to do. Well, there is an easier way. It's called the fundamental counting principle. And this is how we do this one. All we have to do is, there are 3 parts, right? How many is in the first part? We have 2 colors for the first part. The second part, we have 3 colors. And the last part, we have 2 colors. So I multiply these together, which gives me 2 times 3 times is 12. So 12 toys, which is the same answer. That is the easier way of doing it. It's called the fundamental counting principle. Okay? So here's a first example to help us solve this. It says, a math quiz consists of multiple choice questions. 6 multiple choice questions, each of them with 4 answers, A, B, C, or D. So we have 6 questions, 1, 2, 3, 4, 5, 6. Each of them have 4 different answers. So there's 4 choices for each. Just like here, we have 2 choices, 3 choices, then 2 choices. 4 choices for each. So how many test score sheets can there be? Answer sheets? Well, that's the same as 4 times 4 times 4 times 4. Well, that's 4 to the power of 6, which is the same as 4,096. Okay? And that's it. Okay. So, let's take a look at my next one. It says, we're looking now at some restrictions of the fundamental counting principle. So Eric has been assigned the task of determining how many odd 4-digit numbers there are. Now here's a little problem. This is a 4-digit number. This is not, so we cannot start with 0, and it must be odd. So there are 2 restrictions here. First step of his work is shown in the bottom. Explain why the last number is 5. So why did he use 5 for the last number? Well, the last digit must be odd. How many odd digits are there? Well, from the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Can't go any more because we're restarting. How many odd digits do we have? We have 1, 2, 3, 4, 5 different odd digits. So he has 5 options to put in the last one. And we're always going to do our restrictions first. And the most important restriction here is it must be odd. Okay? The next one says, the second step of his work is shown. Explain the reasoning for the number 9. So why did he put a 9 there? Well, I look at this and I know we have 5 odds, but now it can't start with a 0. As soon as I start with a 0, it's a 3-digit number. So he can't choose 0. So now he has 1, 2, 3, 4, 5, 6, 7, 8, 9 others to choose from. That is why he starts with 9 there, because he has the digits 1 to 9 to choose from. Okay? Now complete the work to determine how many 4-digit numbers are there. Well, so he has 5, 9 there. Then the rest, he has 10 to choose from here, all the way from 0 to 10, any of those digits. And the digits 0 from 10 there, so he has 10 digits to choose from. So altogether, he has 4,500 different arrangements. There's 4,500 odd 4-digit numbers. Okay? Now the next part says, he was given a new task. It was to determine how many odd digit numbers there are without any repeating digits. So if I look at that, it says here, explain why the first step, step A, is correct, but not B. Well, let's take a look. Step A, it still must be odd, right? So there's still only 5 there. But now step B, it says is not correct. Why? Because if I use an odd number here, any of these 5, 1, 3, 5, 7, or 6, that means I can't use 1, 3, 5, 7, or 6 there. So in here, I really only have 8 digits to choose from, because whatever is used here cannot be used there. So that is why I cannot, step B is wrong. It's not 9. It is actually an 8. So determine how many odd digit, 4-digit numbers there are. So let's first start with my restrictions. First restriction is it must be odd, so there's 5 to choose from. Second restriction is we can't have a 0, so no 0, and we have 1 less to go from there. So how many do we have to choose from? We only have 8 numbers to choose from. Now, 2 numbers are being used, so here we only have 8 numbers to choose from as well. Now we have 3 numbers being used, so here we only have 7 numbers to choose from. I multiply these all together, I'm going to get 2,240. Okay? So let's look at that again. Right there we have a 5. Why? Because we can only have odd. That's my most important restriction. It's an odd digit. Then I look at it, and we said, well, we can't start with a 0, and we can't have whichever odd number we're using, so we'll go like this. Okay? And then it keeps on counting down, because we keep on using more letters, so we have, or more numbers, so we have less numbers to choose from. So those numbers go down. Next one says, card number plates in an African country consist of the letter first I or 0. Okay? So we have an I or 0, followed by 3 digits. 1, 2, 3. Okay? Of which 0 cannot be the first, so minus 0, no 0 there. Okay? Followed by any 2 letters, 1, 2, which cannot be repeated, no repetition. Okay? So let's follow this up. So first is I or 0. Okay? Oh, it's any other than I or 0. Sorry, anything other than I or 0. So we have 24 options there, because there's 26 letters in the alphabet, and we can't have I or 0, so we have 24 options left. Then we have 3 digits. The first one can't start with a 0, so we have 9 to choose from. Then we have 10 for the next, 10 for the next, because we're allowed repetitions. Now it says, once again, we have a letter, and we have any 26 letters. And then it says for the last one, there's no repetition. So once the letter's used there, we can't use that letter, so there's only 25 to choose from. I multiply this together. And I get something that looks like that. Okay? All right, let's take a look here at example number 5. So it says, there are 2 routes from Pitland to Queensville, 3 routes from Queensville to St. Luke's, 3 routes from Pitland to Rutherford, and 1 route from Rutherford to St. Luke's. So here's the diagram that helps illustrate it. So how many routes are there from Pitland to St. Luke's passing through Queenswood? So we want to go from here to here, but passing through there. So this kind of looks like the tree diagram. I have 2 ways to get there. Okay? And then 3 ways from there to get there. So that is, we have 2 options, and then we have 3 options, which gives me a total of 6 options going through Queensville. Next one says, how many routes are there from Pitland to St. Luke's passing through Rutherford? So I have 3 options to Rutherford. Okay? And then from Rutherford to St. Luke's, I have 1 option, which gives me 3 different routes. Now it says, how many routes are there from Pitland to St. Luke's? So from Pitland to St. Luke's, I could go this way, or I could go this way. Now, anytime we say or, that means we must add. If I look at it, I could go that way or that way. Because if I said this or this, it's 1 plus 1, not 1 multiplied by 1, which gives me 2. This or this or this gives me 3, and we multiplied those. But from this or this, we are going from here and then there. Here it's here and then there. Or we could go. So as soon as I say or, it's adding and is multiplying. So we have 3 plus 6, which is equal to 9. Because I have 3 routes going this way and 6 routes going that way. I could go either this way or that way. So I add them together. There are 9 different routes. Okay? Here we go. Example number 6 says, a telephone numbers are allocated to subscribers. And the rural area consists of the following. We could do this, or we can do that. So the first one has 6 digits, because it's these digits followed by 3 other digits. So these digits, we can only have 3, 4, or 5. So that's 1 option for each. Then, followed by any 3 further digits. Well, we could have 0 to 9. So that's 10 digits, 0 to 9, 0 to 9. Which gives me a total of 1,000. The next one now, it's the digit 2, followed by, so we have the digit 2, followed by any of the digits 1 to 5, well, there's only 1 digit 2, and there's 5 digits from 1 to 5, so hand, and then followed by any 3 further digits. So there's 10, 10, 10. This gives me 5,000. So you could have this for a real number, or this. Keyword is or. What does or mean? Or means we add these. So a total of 6,000 numbers. Okay? Last one here. It says, on this page anyways, and then we have one more page to do. It says, determine the number of distinguishable 4-letter arrangements that can be formed from the word English if any letter could be in any position. So 4-letter words. Okay? So if we're using it, we're grabbing a letter, can't use it again. So English, how many letters are there? 1, 2, 3, 4, 5, 6, 7. Oh, so we have 7 options for the first one. Then that 1 letter is used, so we only have 6 for the next. Now we have 2 letters used for this one, so we have 5. Now 3 letters used, so we only have 4. Multiply those together, and I'm going to get 840. Let's take a look at the next one. The first letter must be an E. Looking at the word English, first letter must be an E. Okay, so it must be an E. Then we have 1, 2, 3 others. So I have 1 option there. Only 1 could be there, because there's only 1 E. Okay, then, since that's used, I only have 6 choices for the next. And 5, it's now 2 letters being used. And 4 letters are being used. Multiply those together, and I'm going to get 120. 65, 30, yeah, 120. Okay? So, now, let's take a look at this next one here. Oops. It says, okay, so this last one says the first and last letters must be vowels. So we must have a vowel here, we must have a vowel there. How many vowels are there? We have E and I. So I have 2 options, and then only 1 option. Because once one's used, there's only 1 left to use. Now, how many other consonants are there? 1. Or how many other letters are there once those are used? There's only going to be 5 to use there, and then 4 to use there. So that's going to give me a total of 40 different words can be made. Let's take a look at the last one. The word must contain a G. Okay, so 4-letter words must contain G. So I could have a G at the beginning. Or, notice the keyword, or I could have a G second. Or I could have a G third, or I could have a G fourth. Now, there's only one G, so there's only one option for those. Then if those are used, I have 6 options for the next one, then 5, because 2 is being used, and 4, because 3 are being used. This one here, if that's used, we always do our restrictions first. I'm going to have 6, 5, 4. 6, 5, 4. Well, these all look the same. So really, each of these are 120, 120, 120, 120. Add these all up, because it's this, I could have a G there, or there, or there, or there. I'm going to get 480. Or I could have just did this multiplied by 4, because there are 4 places where you can put that G, and everything else would be the same. Okay? So 480 is my total. The keyword was or. Okay? All right. Last question. Last question. Okay? As it says, in class example 3, Eric was asked to determine how many odd digits numbers there are. Okay? As an extension to the assignment, he was then asked how many even digits there are. Okay? So part 1 is how many even 4-digit numbers are there? And part 2 was how many even 4-digit number are there if there are no repeated digits? So let's determine part 1. Okay? So we have 4-digit numbers. Okay? Once again, I'll start with 0, but we must have even. How many evens are there? Well, it can end in 0, 2, 4, 6, or 8, right? So this must be even, and we have 1, 2, 3, 4, 5. We have 5 options. Can't start in 0. Okay, so then we have 9 options. Then we have 10 and 10. We multiply all these together, I have a total of 4,500 options. So that's pretty easy. It's the exact same. But now, Eric looked at it for part 2, and he knows there's a problem. Digits can't be repeated. Now, he looked at it, there's 5 there, but now, how many do we put here? 9, because it can't have 0. But if we use a 0 there, what happens? I could have 9 there. If I don't use a 0 there, then I could only have 8. So that's a bit odd. So there's a scenario where we can use a 0, when we use a 0 here, and then there's a scenario where we don't use a 0 there. So there are 2 scenarios. There's using a 0 or not using a 0. Keyword is or. So we're going to have to add 2 different calculations together. So we have one calculation where there is a 0 there. So if there's a 0 there, we have 1 option. That means I have 9 options here, right? Because it can't be 0. Then there's no repeated, so 1, 2. 2 numbers are used, so we only have 8, then we only have 7. I multiply that together, and I will get 504. Okay, let's take a look at the next one. So the next one, we have my 4 digits, and here we're looking at all the digits except for 0. So that's 2, 4, 6, and 8. So we only have 4 options there. Now, this can't be 0 as well. So then we only have 8 options here. So there's that 4, and then there's that. And then we have 8 options, and 7. I multiply this together, I'm going to get 1,792. Now, I could do this or this. So we have a scenario where it ends in 0 or where it doesn't end in 0. So what do I have to do? As soon as I say or, we have to add those together, which will give me 2,296 different arrangements. Okay? So that's everything. Hopefully you understood it. See you tomorrow as we work on the assignment.